Okay, continuing with 6.1, the next example. Let's plot both f of x and f inverse of x on the same set of coordinate axes. And note any restricted domains. Okay, so for number 1, we have that f of x is equal to quantity x plus 3 squared minus 4. So this was a parabola, or is a parabola. So we know that we'll have to restrict the domain, but let's go through the process. So first step, of course, is to let y be in terms of f of x. So y is equal to quantity x plus 3 squared minus 4. Step 2, 2 is to swap x and y, so we get that x is equal to y plus 3 quantity squared minus 4. Step 3 is to solve for y. So rewriting x is equal to y plus 3 quantity squared minus 4. I first add 4 to both sides, so x plus 4 is equal to quantity y plus 3 squared. In order to get rid of the square, I will take the square root of both sides. So x plus 4, the square root, is equal to quantity y plus 3. Now I can subtract 3 from both sides, so the square root of quantity x plus 4, from which I subtract 3, is equal to y. Now that, for the final step, is my f inverse of x. So f inverse of x is the square root of quantity x plus 4, from which I'm subtracting 3. Okay, so x and y coordinate axes. Yep, no, that was not straight. So x and y coordinate axes. What do we have here? X and y. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so I'm going to plot the inverse function first. So remember, this is left 4 and down 3. So I go left 1, 2, 3, 4, down 3, and it's a square root function. So to the right 1, up 1, to the right 4, up 2, to the right 9, up 3. So the square root function looks something like so. So this is f inverse of x. Now let's go ahead and plot f of x. Well, this of course is left 3, and this is down 4. So I go left 3, down 4, 1, 2, 3, 4. And if I go up 1, right 1, up 1, right 2, up 4, right 3, up 9. So it would be a parabola, but I'm only allowed to have that part of the domain on which it is 1 to 1. So even though I should have another part of the parabola to the left, it wouldn't be 1 to 1 there. So I'm only taking the domain of f of x, the restricted domain, to be from negative 3 to the right. So negative 3 to the infinite. So I'm taking the right-hand side of that parabola. But I also want you to notice something. If I look at the main diagonal, actually let me just go ahead and draw it as a full line, if I can. Yeah. Notice that these two functions look like mirror images. So this is the function f of x. They look like mirror images on either side of that main diagonal. Okay, so let's do a couple more plots. So number 2. Let's see, what shall we do for number 2? Let's do that line. So f of x is equal to 2x minus 4, so hopefully this will be easier to do. So the first step, we let y be in place of f of x. Second step, we swap x and y. So x is equal to 2y minus 4. Third step, we solve for y, so x is equal to 2y minus 4. Let's add 4 to both sides. And let's divide by 2. So I get 1/2 of x. 4 over 2 is 2 is equal to y. Okay, and the final step is to call that y f inverse of x. So f inverse of x is 1/2 x plus 2. So these are of the form y is equal to mx plus b. So slope-intercept form of a line. So x and y coordinate axes. Pardon me. Actually, let me move that up a bit. 1, 2, 3, 4. Okay, we'll go to here. So x and y coordinate axes. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And 1, 2, 3, 4. Okay, so let's go ahead and plot f of x, which has a y-intercept of -4 and a slope of rise 2, run 1, rise 2, run 1, rise 2, run 1, rise 2, run 1, etc. So this is f of x. And now let's plot f inverse of x, which has a y-intercept of +2 and a slope of rise 1, run 2, rise 1, run 2, rise 1, run 2, rise 1, run 2. So this is f inverse of x. And once again, if we look at the main diagonal, it looks like that these are mirror images on either side of the main diagonal. Okay, let's do one more. So number 3, let's say that we have f of x is equal to 1 over x plus 2, to which I'm adding 3. Do you know, that does not look very good. Let me make that better. So 1 over x plus 2 plus 3. Okay, so first we write this as y is equal to 1 over x plus 2 plus 3. Then second step, I'm going to swap x and y. So x is equal to 1 over y plus 2 plus 3. The next step, I'm going to solve for y. 1 over y plus 2 plus 3. So let's go ahead and subtract 3x minus 3 is equal to 1 over y plus 2. And now I can cross multiply. Let me write that a bit better. So I'm going to swap the numerator on the left for the denominator on the right. So I get y plus 2 is equal to 1 over x minus 3. Now I can just subtract 2. So y is equal to 1 over x minus 3 minus 2. And I'm going to call that, the final step, my f inverse of x. So f inverse of x is 1 over x minus 3 minus 2. Okay, so x and y coordinate axes. Let's see. X and y. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, something like this. Okay, so let's go ahead and first plot f of x. So I notice that x plus 2 is left 2, and plus 3 on the outside is up 3. So I'm going to go up 3. So I'm going to go to the left 2 and up 3. And notice that 1 over x has both horizontal and vertical asymptotes through the origin. So if I'm left 2 up 3, the origin is left 2 up 3. Oh, that looks terrible. Let me try to make that better. Okay, and then it's at 1, comma 1, wherever that moves to. So f of x looks something like so. Oops, terrible. And similarly, it's symmetric. It's got origin symmetry. Where now the origin has been moved. So this would be f of x. Put f of x up here. Now let's plot f inverse of x. So notice this is right 3 and down 2. So what does that mean? That means that my asymptote's going to go right 3 and down 2. That would be the origin point for this. Right 3, down 2. Okay. And of course I'm at the points 1, comma 1. So f inverse of x is going to look something like so. See if I can draw this well. Kind of hard to draw this, but that's okay. Hopefully you get the idea. So this is f inverse of x. Okay. Okay, so let's once again notice the main diagonal. And yes, it looks like these are indeed reflections of one another across the main diagonal. Okay, so let me note that before I end this video. Okay, so note. So the graph of f inverse of x, the graph of f inverse of x is a reflection of the graph of f of x across the main diagonal. And the main diagonal, it has diagonal that is across a line. The line y is equal to x.